The James Webb Space Telescope JWST project guaranteed the most point-by-point and most keen infrared photos of distant systems looking into the past to help address puzzles with respect to the universe's starting points subsequent to going over 1,000,000 miles from Earth and spending months preparing to gather information from the external locales of room. The telescope has previously started communicating full variety photos to NASA by permitting us to see stars and systems as they were a long time back. The telescope permits us to look further into space than before. From that point forward, the groundbreaking NASA project has created a predictable stock of stunning pictures. The JWST just as of late delivered sharp and itemized pictures that are awe-inspiring. Obviously, the JWST isn't just there to blow our minds as indicated by NASA specialists. Its work will be significant for understanding both the universe as it is currently and its initial history. What new data and information do we have from the JWST and the Hubble Space Telescope? How about we figure out the James Webb Space Telescope, which is, as of now, notable for its enthralling photos of the universe, has succeeded yet again with its most memorable picture of Neptune. NASA's James Webb Space Telescope shows its capacities nearer to home, as well as giving the best brief look at the planet's rings in more than 30 years. Webb's cameras additionally shed new experiences on the ice Goliaths, the lucidity of the planet's rings, some of which have not been seen since NASA's Explorer 2 turned into the primary shuttle to look at Neptune during its methodology in 1989, stands apart generally in Webb's most recent photo. The Webb picture clearly shows Neptune's fainter dust groups in expansion to numerous splendid thin rings. As per Heidi Hamel, a Neptune framework trained professional and transdisciplinary researcher at Webb, it has been a long time since we last noticed these faint dusty rings, and this is the first time we have seen them in the infrared. These staggeringly frail rings were found so near Neptune on account of Webb's especially steady and exact picture quality. Since it was found in 1846, Neptune has spellbound researchers. Neptune circles in the far-off dim region of the external sunlight-based framework multiple times further from the sun than Earth. High moon on Neptune is tantamount to grown-up dusk on the planet. In light of how little and pale the sun shows up from such a huge span away, the inward compound arrangement of this planet qualifies it as an ice monster. Neptune is considerably more extravagant in components, heavier than hydrogen and helium than the gas monsters Jupiter and Saturn. Little groupings of vaporous methane empower Neptune to show up naturally blue in Hubble Space Telescope photographs at noticeable frequencies, which is effectively perceptible. Neptune does not appear to be blue to Webb on the grounds that its close infrared camera close to cam just sees objects in the close to infrared range, somewhere in the range of 0.6 and 5 microns. Truth be told, the planet is genuinely dark at these close infrared frequencies due to the significant retention of red and infrared light by methane gas, with the exemption of regions with high height mists. These splendid streaks and spots of methane ice mists are recognizable since they reflect daylight before it is consumed by methane gas over the years. Pictures from different observatories, for example the W.M. Keck Observatory and the Hubble Space Telescope, have caught these quickly changing cloud. Includes a more discrete visual mark of the overall air dissemination that powers Neptune's breezes and tempests. Could be a slim line of brilliance orbiting the planet's equator. At the equator, the air brings down and warms, making it lighter in infrared frequencies more than the close by cooler gases. Neptune's northern pole, close to the highest point of this picture, is barely far away for stargazers due to its 164e circle, yet the Webb pictures recommend a strange splendor there. Webb's picture obviously shows a formerly known vortex around the southern pole. In any case, this is whenever Webb first has shown a constant band of high scope mists encompassing its 7 of the 14 known moons of Neptune were 2, found by Webb an exceptionally splendid mark of light with the particular diffraction spikes saw in a large number of Webb's photos overwhelms this Webb painting of Neptune. Anyway, this item isn't a star, this is Triton, the large odd moon of Neptune. Triton reflects around 70% of the daylight that it gets thanks to a frozen covering of consolidated nitrogen, covering it on the grounds that methane ingests at these close to infrared frequencies. It surpasses Neptune by a huge wiggle room in this photo. Triton's exceptional retrograde circle around Neptune has driven stargazers to theorize that this moon was once a Kuiper belt object that was gravitationally got by Neptune. Moreover, the James Webb Space Telescope has taken its most memorable pictures of Mars by delicately noticing infrared light starting from the planet on September 19th at the Europlanet Science Congress EPSC 2022. The first photographs and spectra of Mars from the James Webb Space Telescope were unveiled on September 5th, 2022. JWST took the photos and estimations from its inexact million-mile 1.6 million kilometers distance from Mars. The pictures of Mars perceptible disk or the side of the planet confronting the telescope that is enlightened by the sun were taken by networks close infrared C camera NCAM. They could offer planetary researchers an unmistakable viewpoint of Earth's nearby neighbor. Furthermore, convey information that can be utilized in conjunction with perceptions made by wanderers like NASA's tirelessness and objects in the Martian circle. It isn't the least difficult item for the JWST, which is intended to notice very far off. Furthermore, faint items to see since Mars is generally close and profoundly brilliant. Stargazers can concentrate on present moment peculiarities like Martian atmospheric conditions, dust tempests, and even changes welcomed on by the planet's seasons thanks to the JWST capacity to take pictures and spectra with the spatial goal they require. The Webb telescope likewise considered synchronous perception of occasions that happen all through the Martian day, counting over the course of the day. Nightfall and evenings. The eastern half of the globe of Mars is portrayed in 2 distinct frequencies of light in the JWST. Starting photographs of the planet reflected daylight overwhelms the short frequency picture, which portrays components of the Martian territory that imitate those noticed imperceptible lights. These highlights incorporate the curious significant P. dim volcanic stone and Hypa's hole A, almost 280 m wide, 450 kilometers influence cavity. The light that Mars discharges at longer infrared frequencies as it loses heat was caught by the NCAM camera on the Webb satellite telescope. The most brilliant, what's more, hottest locale of this light is seen where the sun is basically straightforwardly above the planet and is connected to the temperature of Mars and its climate. The splendor diminishes in the northern half of the globe of the planet, which is as of now encountering Martian winter, and in the polar areas of Mars that get less daylight anyway. The measure of light that scopes the JWST is not exclusively reliant upon the planet's temperature. The synthetic cosmetics of the Martian environment and surface can likewise be construed from the telescope's photographs. Cosmologists might have the option to find out more about Mars' environment and surface by utilizing information from the James Webb Space Telescope to investigate the range of light that was recognized coming from the planet during the hottest piece of the Martian day. The 1,200-mile 193 km Halley's Bowl appears to be hazier than its environmental elements as per an investigation of the JWST photographs. This affects structures. Clear obscuring is the aftereffect of lights entering the Martian climate. What's more, being consumed via carbon dioxide. The new photos likewise show how the James Webb Space Telescope might explore Mars, utilizing estimations made with the telescope's close-to-infrared spectrograph N. Speak instrument, a strategy known as spectroscopy. Planetary researchers can use spectroscopy to dissect the fingerprints that various synthetic substances leave in the light moving from a planet's air to lay out its creation. Since compound components ingest and emanate lights at very specific frequencies, the researchers starting discoveries uncover otherworldly designs that are encoded with subtleties about Martian residue, frozen mists, all of which make up the climate and the sorts of minerals that can be seen as on the planet's surface: water, carbon dioxide, carbon monoxide, and other compound parts ought to be noticeable by JWST perceptions. Methane is critical, since it can illuminate planetary researchers about an assortment of topographical processes happening on Mars, including whether a huge item has, as of late, struck the red planet from space. Methane may likewise give proof of past natural action on the planets, the principal obvious sign of carbon dioxide in an extrasolar planet's climate has additionally been recorded by the Webb telescope. The disclosure not just offers charming hints with respect to how the exoplanet grew, however, it additionally serves as a review of what's in store when Webb explores to an ever-increasing extent extraterrestrial planets. The disclosure displayed in an information plot that misses the mark on splendor of Webb's prior photographs, which highlighted universes trapped in a grandiose dance and stunning mists in a star nursery. Anyway, the information are lovely, as per Jesse Christensen, an stargazer at the NASA Exoplanet Science Organization at the California Establishment of Innovation in Pasadena. The exoplanet WASP-39b is known as a hot Jupiter by researchers since it has a breadth like Jupiter, however circles its star considerably more intently than Mercury circles the Sun, making it incredibly warm. The plot, or then again range, gives itemized data about the climate of the exoplanet. The planet, which is more than 200 parasecs away from Earth, was first spotted through ground-based concentrates in 2003, and it was subsequently found by NASA Spitzer Space Telescope, which was functional from 2003 to 2020 in spite of the fact that the last's information were uncertain. They raised the likelihood that WASP-39b air holds back carbon dioxide. Webb then, at that point, came into the image on July 10th. The infrared telescope followed the planet as it got across the substance of the star for barely 8 hours. During this period, daylight infiltrated the air of the planet and was consumed by particular particles at specific infrared light frequencies. Researchers addressed whether carbon dioxide would show itself as a noticeable blip in the range. Natalie Batalha, a space expert at the College of California St. Nick Cruz UCSC, is the group pioneer for networks traveling exoplanet early delivery science, and there it was simply leaping off the PC screen. She says the results expanded certainty that Webb will be a game changer for exoplanet research. The telescope is requested to notice 76 exoplanets in its most memorable year of activity alone. The all-out could reach hundreds all through its lifetime. It will look through the environments of little possibly Earth-like rough universes and gas Goliaths. Tracking down carbon dioxide, however, is noteworthy all by itself. One may sensibly guess that a planet like Jupiter, which sprang from a similar circle of issue as its star, would share the star's compound creation, yet not one or the other. For WASP-39b nor for our planetary group is it the case. Solid carbon dioxide signals from the exoplanet show that it is stacked with components heavier than the hydrogen and helium that typically make up stars. For what reason is the main thing. The account then, at that point, starts to get the fact that comets and make steam it plausible. Space rocks hit WASP-39b when it was youthful, conveying heavier components like carbon. What's more, oxygen taking note of that is intriguing. The exoplanet seems to contain the same amount of weighty components as Saturn, which space experts accept. Moreover, had a tempestuous youth. The fact that WASP makes then again it conceivable. 39b developed from components in the frosty external restrictions of its planetary framework. Prior to moving internal when it arrived at its extreme resting place it was near, its host star which might have impacted away piece of the hydrogen from the exoplanet's air, focusing the heavier components and improving them with carbon dioxide for articles that will inspect these conceivable outcomes and examine the planet range in much more profundity, are presently being worked on by researchers, tracking down carbon dioxide in a planet's air is the most vital phase in finding life beyond Earth. WASP-39b is thought about excessively near its star for it to help life, as per cosmologists, who likewise don't expect the Webb telescope to find evident proof of extraterrestrial life. Carbon dioxide and methane in a planet's environment are believed to be indications of life, as per space experts. Eventually, finding life will presumably require an observatory extensively more refined than Webb, yet for us to be ready for that innovation in the future we should get past this unimaginably critical time. Then again, the Hubble Space Telescope has made a huge headway in its mission to decide the rate at which the universe is growing, which is reliable with the thought that something peculiar is going on in the universe. Cosmologists have, as of late, used telescopes like Hubble to definitively measure how rapidly the universe is extending, yet as those estimations have worked on in precision, they have additionally uncovered a peculiarity when contrasted with perceptions made soon after the enormous detonation. There is a critical distinction in the paces of the universe's development as it is now. That uniqueness is outside the ability to understand of researchers. However, it suggests that something strange is going on in our universe, which may be the result of pristine, unseen material science. For the beyond 30 years, Hubble has been collecting information on an assortment of milepost markers in reality which can be utilized to screen the speed of the universe's extension as it gets farther and further away from Earth. As per NASA, it has presently aligned more than 40 of the markers, empowering considerably more accuracy. The Nobel Prize champ Adam Ree of the Space Telescope Science Organization (STS) and the Johns Hopkins College in Baltimore, Maryland, said in a proclamation, "You are getting the most dependable proportion of the extension pace of the universe from the highest quality level of telescopes and infinite mile markers." When American space expert Edwin Hubble saw that cosmic systems outside of our own seem to get away from us, and doing so quicker the further away they are from us, the quest for a exact gauge of how rapidly space was growing started from that point forward. Researchers have been searching for a better clarification of that development. This is a period of incredible disclosures, and we are hanging around for every one of them. Gratitude for watching one more episode of Explorer.